Now, we've had search capabilities for documents and websites and the whole internet for decades. So how is semantic search different?
Yeah, it's a great question. So, search engines started by essentially searching over text strings. So you type in, say, a few characters like Peter, and then it'll search through all the text in its database to find that exact sequence of strings. That was sort of the initial type of search. Obviously, it's problematic. Say you've misspelled the name, or say you're talking about a concept. Say you're talking about a dog, and the article that you're searching over refers to canine or something like that. It won't find any of that. That's where we come into something called semantic search, which is where the search engine knows the meaning of what you're searching for, and it knows how to do things like handle misspellings and things like that. So those are much more sophisticated search engines, and companies like Google spent thousands and thousands of programmer years essentially making their search engine be aware of the semantic information in the document to make a high quality search. So the great thing about using vector embeddings and using large language models for search is that you essentially can get to the quality, almost to the quality of Google search, just by using a model and feeding the text through it and using vector embeddings and doing vector search. You don't need, thousands and thousands of programmer years of work to build your own search engine.
Yeah, it certainly seems incredibly time consuming trying to work out which words are synonymous or nearly synonymous with other words, and to have that done for you automatically has got to be a huge productivity boost.
Exactly, and it's very, very complex. And again, like companies like Google and Microsoft have thousands of engineers like making that work really well. And in a sense, you can think of these large language models as sort of, in one fell swoop, allowing people to essentially reproduce that level of quality, if not better in many cases.
You also mentioned image search before. So that seems like a very cool idea, but I'm not quite sure when you would use it. So what are the sort of business applications of image search?
Yeah, it's a good question. So there's different types of use cases. There's two types. Image search is we call it a classification problem. So we have classification and we have extreme classification. So classification would be like, hey, this thing here is a hamburger. This is a picture of whatever. Say you're building a website where you can search over food or things like that, and people are uploading pictures of their dinner. So you can sort of figure out what that dish is. Extreme classification, on the other hand, is where you're actually trying to find an individual. So, for example, if it's people, you can do like face recognition. So if you have like millions of faces in your database, and you're building a system to verify your identity or some sort of security system, and you take a picture of yourself, that it can actually find an exact match of that face. Classification would say, hey, this is a face, or this is a person. Extreme classification would say, oh, this is Peter, this is Elan, this is John. So both of those can be supported by these techniques and by vector databases. And again, many different use cases.
Yeah, I can certainly see how there's different levels of difficulty there. So just saying, is this a person in the video is much easier than is this Elan in the video?
Exactly. So for example, like people have used Pinecone for security systems, for like if you think of a company that has security cameras, and they have thousands of cameras with feeds of video, and you want to find anomalies, like situations that are unexpected, like, oh, a person is now going through that doorway in my data center, which people don't usually go through. Like, I'd like to get an alert. So that's the kind of thing that you could build using a vector database.